Yeah, very good afternoon. So, till last class, we have studied about a DC circuits. We have solved the DC circuits using different theorems. We have applied KCL, KVL, nodal analysis, mesh analysis to DC circuits, and we tried to find out current through different branch or voltage across different branches and power across different branches. Now, next, what we are going to study is about AC circuits. So before going to go for AC circuits, let us recall whether we understood the difference between AC and DC. Okay. So generally, what is a DC current? DC current is provided by a generator which can provide you a constant potential difference between the 2 points. For example, you take your battery. Okay. So the battery can give a constant 1.5 volts across the battery. If you connect any resistance or any small LED, okay, this voltage by that resistance, that amount of current is going to be flowing. Okay. So what is a battery? Battery is an example of DC generator. The current coming from the battery is called as a direct current. So how we can distinguish a direct current from a alternating current? So the direct current flows only in one direction. For example, I will connect a resistance here. The direct current always flows from plus terminal of a battery, flow through the resistive load and come back to negative terminal. So the current direction of a DC voltage or current will be a constant and it is having a fixed direction. So batteries, your solar panels are the example of DC generators. Okay, batteries and solar panels are the examples of DC generators. How we can measure whether the voltage generated by the battery is pure DC or not? Connect this DC battery or solar panel to your oscilloscope. If the oscilloscope will give a constant voltage, for example, it is maintaining a constant 5 volts. Okay, so for any number of time you connect your solar panel, take out one solar panel, connect to oscilloscope. Oscilloscope is used to measure the voltage and current. So if the oscilloscope is showing a constant line with a positive magnitude, it means it is a DC generator and the voltage generating by the DC generator is 5 volts plus 5 volts. Okay, that is about DC. When you apply a DC, the current flowing is also a fixed. So let the resistance is, for example, 3 ohms. Then the current flowing is a constant value given by V by R, that is 0.5 ohms, 0.5 amperes. So clearly, the generators of a DC voltage are either battery, you can take lead acid battery or lithium ion battery or any sort of battery, or else we can go for a solar panels or solar cells. So they will generate a constant DC voltage. When you use constant DC voltage, the currents flowing through the circuit will be constant. Those circuits are called DC circuits. Now let us understand what is AC. Okay, so the home, whether all the home appliances will work on AC. So you want to take out the AC power supply. There are sockets provided in your home. You can plug in into sockets and connect the device so that it can take a AC supply. So what the AC supply is? AC supply consists of basically 2 points. One point, how DC supply consists of 2 points, plus and minus. Okay, plus is fixed, minus is fixed. In the same way, to get a AC supply or single phase AC supply, we need a socket. One side of the socket is called as a phase, another end of the socket is called neutral. So the AC voltage is provided between phase and neutral. Remember, phase and neutral are not constant, there will be continuously varying. So we cannot say that phase is always at higher potential with respect to neutral. But in DC, we can say one terminal as plus, one terminal as minus, and always positive terminal will have a more voltage compared to negative terminal. And you might have seen there is one more point in the socket. So this socket is called as a earthing point. This point is called earthing point, or else in advanced circuits you might be seeing a symbol like this, earthing symbol. So these point of a socket will protect a person who is working on this AC by any chance he is working on a iron box. Okay, so by any chance any one of the wire is touching the body of the iron box, so the person who is working with the iron box will get a shock. Example, if there is no earthing, you touch your CPU, which is made up of metal, you might feel a shock. That means this earthing terminal is used to protect the person who is working on this 230 volts. So what is a AC supply is? AC supply is a voltage source whose voltage is not constant with respect to time. The voltage will be continuously varying. The magnitude of the voltage will be continuously varying. So if it will continuously varies periodically, then it is called AC supply. Then it is called AC supply. So when you give an alternating voltage to any equipment, the current drawn by the equipment is an alternating current. So alternating current will continuously changes its magnitude as well as direction. Okay. So generally in UK or India, the voltage which we are going to get is 230 volts with 50 hertz supply. If at all you went to US for your studies, so in US you will not get a 230 volts or 220 volts. We are going to get 110 volts AC supply with 60 hertz. Okay, so what is an alternating current? Alternating current is a current whose magnitude is varying with respect to time periodically. That means after each and every time period, same cycle is going to repeat. Okay, then number of cycles per second is called frequency. Okay, so AC voltage will have, okay, varying magnitude, varying its direction, but have a constant frequency. Okay, so we cannot define a AC supply with single value. I cannot say that voltage across this plug is 4 volts. We have to represent the AC waveform with respect to sinusoidal signal. Okay, how we can represent, how we can handle the alternating waveform, we'll see in the coming up slides. So what is basic difference between DC and AC? In DC, we'll have a constant voltage. Whereas in AC, we will have a voltage whose magnitude and direction is changing with respect to time. Okay, so we can restrict the peak value of a varying value. So how we can define with respect to peak value? If this peak value is 10 volts, so maximum voltage it can give is 10 volts. If this peak value is 100 volts, maximum voltage it can give is 100 volts, but it will not give 100 volts throughout the time period. So the magnitude is changing with respect to time and the direction is also changing with respect to time. So AC waveform is represented by the voltage along with the frequency. Standard AC voltage in India is 230 volts 50 hertz. In US is 110 volts 60 hertz. So when you connect a AC supply to the CRO after stepping down the voltage, you can see a alternating waveform in a CRO. So why we are going for a AC rather than DC? Because the energy cannot be destroyed. Okay, so we can convert one form of the energy to other form of the energy. So what is the sources of electrical energy generation? So primary source of electrical energy generation is coal. The coal is combustion under a furnaces and the steam from the coal is used to rotate the turbine and convert the mechanical energy to electrical energy. That power plant is called thermal power plant. Okay, so in Vijayawada we have a thermal power plant. In Raichur, Shaktinagar we will have a huge thermal power plant. So in general, in thermal power plant, what we are doing, we are converting heat energy to mechanical energy to electrical energy. Second source of electrical energy generation is water. So what is the power plant which will utilize water is hydel power plant. Example, Srisalam power plant. So Srisalam, a dam will be, a reservoir will be constructed to raise the potential energy of the water. Now the potential energy of the water is converted into kinetic energy to rotate the turbine blades. So the potential energy of water is converted into kinetic energy, that mechanical energy is converted into electrical energy. Example of these phenomena is used in hydel power plant. Example, you can take Srisalem power plant, which will generate the energy uh, on both left bank as well as right bank. So another advanced or majorly used nowadays is nuclear power plant. Okay, so in nuclear, as you know that whenever uranium atom, okay, will be coming under the nuclear fission, okay, there will be huge amount of electric energy will be developed or dissipated. So if you control that nuclear emission and convert that nuclear energy into electrical energy, that is your nuclear power plant. So these power plants will always generate a AC power, because they can step up the voltage or step down the voltage using a transformer. In AC, I can easily step up the voltage or step down the voltage using a simple equipment called as a transformer. But in DC, we cannot step up the voltage or step down the voltage so easily. Because of this equipment transformer all over the world, the generating power is AC power. Okay, the generating power is AC power. Now, so what we are going to do in this classes, we'll study the basics of AC circuits. What is the AC generator? What is the physics involved in order to study the AC generator? After that, we can go to the AC circuits. So what is the alternating current? An alternating current is the one whose direction and magnitude is changing with respect to time, and that the cycle of variation is repeatedly exact for each and every direction. So we can generate either sinusoidal waveform using our generator. We can also generate the square waves, or we can also generate the triangular waves. So any shape can be generated. What is alternating current is a positive half cycle should be a mirror image of a negative half cycle. Any waveform whose positive half cycle is a negative cycle, mirror image of negative cycle, and these positive half cycle and negative half cycle together called as one cycle will be continuously repeated. So the time taken to complete one cycle is called time period. You might have studied about periodical waveforms, non-periodical waveforms in your physics during +2. Okay, so we have to consider a periodical waveform of any shape, okay, whose positive half cycle is equal to negative half cycle, and the complete cycle will be continuously repeated for each and every time period. We can generate a square wave, we can generate a triangular wave, we can generate a sinusoidal wave, but we will try to generate always sine wave. All over the world, whenever you want to generate an alternating current or alternating voltage, most 99% they'll try to develop a sinusoidal waveform. There is a logic behind that, there is a mathematics behind that, because if you take a differentiation of a sine, it will result into cosine waveform, which is also a sine waveform with a phase displacement of 90 degrees. So what is d by dt of sine theta? D by dt of sine theta is cos theta. So if at all you use a sinusoidal waveform to do the mathematical analysis for the circuit, it will become simple, because the differentiation of a cos is simply a cosine waveform. The difference between sine waveform and cosine waveform is, if this is a sine waveform, if you apply differentiation, it will become cosine waveform. The magnitude and frequency will remain same. Only it has been shifted by 90 degrees. So this is your sine waveform, this is your cosine waveform. So if you develop a sinusoidal waveform, mathematical analysis of the circuits will become simple, because integration of a sine will become cosine, differentiation of a sine, cosine will become sine. So the shape of the waveform will remain same, only there is a phase displacement by 90 degrees. That is the reason we will try to generate always a sinusoidal waveform. But if it is a triangular waveform, to represent a triangular waveform with a simple mathematical equation, it is very, very difficult. And once you differentiate this triangular waveform, it will result into some other shape. If you differentiate a square waveform, okay, it may be resulting into pulse, something like this. If we integrate, it will result into a triangle. Okay, the shape will changes, as well as we cannot represent. How we can represent a sinusoidal signal? Very simple. A into sine theta, we can easily represent mathematically if we develop a sinusoidal waveform, where A represents the peak value, sine is the sine waveform, theta. You want to represent in terms of the frequency, replace theta with omega t, where omega is the angular frequency. Okay, so it is always easy to represent a sinusoidal waveform. We can differentiate a sine waveform, we can integrate a sine waveform. So it is better to use or generate a sinusoidal waveform. So what is the physical law behind generation of AC waveform? How we can develop a AC waveform or AC voltage? So the basic physical law which gives the how to generate a AC voltage is, okay, Faraday's law of electromagnetic induction. What Faraday's law of electromagnetic induction is says that take a current carrying conductor of length L. Okay, place this current carrying conductor of length L under a magnetic flux density of B. Okay, when the current carrying conductor is moving with a velocity V, then a EMF will be developed in the current carrying conductor given by E is equal to BLV sine theta, which you might have studied in your physics, that E is equal to BLV sine theta. Okay, now if this velocity is a translatory motion, velocity means you are moving in forward direction or backward direction. So what if if at all you are being moving in a angular motion? Okay, so that is called rotational motion. The angular velocity is translatory velocity is V, angular velocity is omega. So what is the units of velocity? Meters per second. What is the angular velocity units? Radians per second. These are all the basics which we need to remember. Okay, if the conductor is moving with a angular velocity of omega radians per second under a magnetic field of B, okay, then it is going to cut the magnetic lines of force. EMF will be induced in it. So Faraday's law says that the magnitude of EMF is directly proportional to rate of change of flux linkages. So how to create a magnetic field? Take one north pole, take one south pole, place north pole and south pole, a magnetic lines of forces are created. This will create a uniform magnetic field. Generally I can use permanent magnets which are made up of nickel or alloys, or else I can use a, what is the other way? I can use electromagnet. How to form an electromagnet? Take an iron piece, wound a coil around a iron piece, give a DC supply to this. Then this iron piece will act like a magnet. So if the coil on one side of iron piece is in clockwise direction, wound a coil on other iron piece in anti-clockwise direction, so that the current direction here is in clockwise, here the current direction is in anti-clockwise. So this will act like a south pole, this will act like a north pole. So uniform magnetic field is being created. Now a piece of a wire which is carrying a current, or else in which EMF should be taken. So generally we will select a copper wire or copper coil. Okay, so when the copper coil is moved forward or backward or circulatory, the coil or conductor cuts the magnetic lines of force, then EMF will be induced in the current conductor. That is called electromagnetic field, or this principle is called electromagnetic induction. So remember, what is the difference between EMF and voltage? EMF is applicable. Okay, EMF is also a voltage developed in a conductor. because of electromagnetic induction principle. Generally, we will refer EMF for a DC generators or AC generators. Whenever there are generators and motors, we will use EMF. Whenever there are batteries or solar cells, we will use voltage. But EMF is a voltage generated in a conductor because of electromagnetic principle. So that is about what is EMF. Generally, we'll now in AC generators we'll say the EMF induced is 20 volts. EMF is nothing but the voltage generated or developed in a coil is 20 volts. Why it is called as a electromagnetic field? Because this is the field which are voltage generated because of electromagnetic induction principle. So what is electromagnetic induction in nutshell is whenever a conductor is changing or else moving with a velocity v under a magnetic field, EMF will be developed in that conductor. That EMF is given by E is equal to BLV sin theta. I'll explain once again one more principle which is not referred to here, but that will be used in a motor. So if you take a current carrying conductor, okay, if you take a current carrying conductor of length L carrying a current of I, okay, placed under a magnetic field of B, then a force will be experienced in a current carrying conductor. That force is given by F is equal to BIL sin theta, which you might have studied, BIL sin theta. This is also electromagnetic induction principle. So this principle is used in motors where current carrying conductor is placed under magnetic field, it will experience a force. That is used in motor principle. What is the principle? What is the electromagnetic induction principle used in generators? Is a conductor of length L is moving with a velocity v under a magnetic field of B, then EMF will be induced in that. Okay, this principle, this electromagnetic induction principle, is used in generators. So how we can place, how we can analyze the EMF induced? Okay, so you can see there is a galvanometer connected to the end of the conductor. So which will measure whether the EMF will be induced in this. Now, if this conductor is rotated continuously with certain speed, okay, so when the conductor is in this position, it is directly under the influence of south pole. Okay, so it is cutting the magnetic lines of forces, EMF will be developed. When the conductor is exactly in middle of north pole and south pole, it is neither under the influence of north pole nor under the influence of south pole, it is not going to cut the conductor like magnetic lines of force, EMF induced is zero. When the same conductor comes under the influence of north pole, okay, EMF will be developed but in opposite direction. If the EMF is developed in downward direction here, the same conductor when it is under the influence of north pole, the EMF developed in the wire is upward direction. We mean to say is that moving the wire through the magnetic field, EMF induced in a galvanometer. If the conductor is under the influence of north pole, the galvanometer is moving in right hand side direction. That means the EMF induced is positive. If the same conductor is coming under the influence of south pole after 90 degrees of rotation, the galvanometer is showing a negative voltage. That means it is cutting the magnetic lines of forces, but EMF induced is in negative direction. So very simply how we can construct a AC generator is take one conductor, rotate the conductor under magnetic lines of force. Okay, so whenever the conductor under south pole, it will give negative voltage. In between north pole and south pole, zero voltage. When the conductor comes directly under the influence of north pole, positive voltage, and then between north pole and south pole, zero voltage. That means for one complete rotation, let us start from south pole, or else let us start from middle of north pole and south pole. When the conductor is in middle of north pole and south pole, no EMF is induced. When you rotate 90 degrees, so exactly under north pole, maximum EMF is developed in positive direction. When you move out from north pole, EMF induced will reduce because the conductor is slowly going into magnetical neutral axis after 90 degrees rotation. Now once you increase at 135 degrees, your conductor will be coming directly under south pole. So negative voltage, negative max. When you rotate further, the conductor reach once again magnetic neutral axis. So for one 360 degrees mechanical rotation, I can get one alternating EMF waveform. So this is 2 volts and this is 2 volts. So we can say EMF developed is 2 sine omega t. So here's the one who has identified or given the Faraday's law of electromagnetic induction. So what he means to say is that how I can increase the voltage induced in a conductor. If you move faster your conductor, the EMF induced. That means EMF induced in a conductor is directly proportional to angular velocity or omega. Angular velocity or omega. So if you rotate with more speed, it will cut more number of flux lines, more EMF will be developed. Or else you can increase the magnetic flux density using a stronger magnet. Okay, so by using a stronger magnet, the flux will increase. E is directly proportional to flux. So you increase the speed of that. You can represent the speed either in radians per second or revolutions per minute. For example, you are able to rotate this conductor with 60 rotations per minute. If you connect it to a motor, it can rotate at 300 revolutions per minute. Okay, as the number of revolutions per minute increases, EMF increases, as well as EMF is directly proportional to flux. Stronger the magnet you use, stronger will be the voltage developed or EMF developed. Or else you increase the length of the wire. Instead of increasing the number of wires, you can see increase the number of coils or number of conductors. If you increase the number of conductors, automatically EMF induced is also increased. Okay, so the EMF induced in a AC generator is proportional to rate of change of magnetic flux lines cut by the conductor. So E is directly proportional to d psi by dt, which you might have studied in your physics. What is psi? Magnetic flux linkages. So E is directly proportional to n d phi by dt. N is equal to number of turns. Phi is equal to flux. Okay, so let us see the animation wherein it's not playing. Okay. So the direction of induced EMF in a particular conductor. How we have developed a conductor? We have taken a single rectangular loop. This is called as a single rectangular loop. A single rectangular loop consists of two conductors. Let this conductor is A, B, and there is one more conductor between C and D. Now, when the conductor comes under the influence of north pole, okay, let the current direction is downward direction. If the other end of the, we have taken rectangular loops as that AB if comes under north pole, CD will comes under south pole. So EMF induced in this is +2 minus, and here it is +2 minus. So total voltage, if you apply KVL, this is 2 and this is 2. So current direction, this is plus minus. So this will be plus, this will be minus. Both voltages are adding, you'll get 4 volts. Now what will happen is that you can see whenever the conductor is changing after 90 degrees, the voltage is changing from negative to positive. Negative to positive. Now, when these same conductor after 90 degrees rotation, okay, AB will come here, CD will go here. Okay, and this is B, and this is A, and this is C, and this is T. Now the current direction is changed. So here it is downward direction, here it is upward direction. So we will get plus 2 minus 4 volts. Plus 2 minus 4 volts. Now the direction of induced EMF is given by famous law which you might have studied in your intermediate or else in your physics, that is Fleming's right hand rule. What the Fleming's right hand rule says that place your thumb and forefinger and second finger. Yeah, you can just assume. So this is your thumb, your forefinger, and then second finger at 90 degrees to each other. At 90 degrees to each other. If thumb indicates motion of the conductor or direction of rotation, thumb indicates direction of rotation, then forefinger indicates direction of flux, then resultant second finger indicates direction of induced EMF. So place your thumb, forefinger and second finger perpendicular to each other, perpendicular to each other. If thumb indicates the direction of rotation, for example, it is rotating in clockwise direction, and forefinger indicates the direction of flux, then second finger indicates direction of induced EMF. So that is given by Fleming's right hand rule. Fleming's right hand rule is used in DC generator or AC generator to determine the direction of induced EMF. Other law which also used to find out direction of induced EMF, not exactly in generator, in linear motion, or else for example, your conductor is not rotating, flux is changing with respect to time. Flux linking with the coil is changing with respect to time. So even then also EMF will be induced. That direction of EMF is given by Lenz's law. Okay, so there are two types of EMFs. One is dynamically induced EMF. Dynamically induced EMF is used in generators where the conductor is rotating, magnetic field is constant. Another induced EMF is statically induced EMF. Statically induced EMF, the conductor is constant, the flux linking with the conductor is changing with respect to time. Then it is called statically induced EMF. In statically induced EMF, flux is varying. In dynamically induced EMF, flux is constant, conductor is rotating, coil is rotating. Okay. So this is the animation. You can see whenever the conductor crosses this magnetical neutral axis, the current direction will changes. Okay, upward direction will become downward direction. Let us see in this animation. There is a rectangular coil A and B, C and D. When A and B is coming under north exactly in between north and south pole, no EMF will be induced. So this is your Fleming's right hand rule. So keep your thumb in a direction of rotation, forefinger in direction of flux, second finger induced EMF. You can see when AB is under the influence of south pole and CD under north pole, you will get positive voltage. Vice versa, you will get a negative voltage. This is a GAF, I cannot stop it, but ample number of animations are available to see after crossing the magnetic and neutral axis, the EMF induced is changing. When same AB is under the influence of, when AB is under the influence of south pole and CD under north pole, positive voltage. If AB is under the influence of north pole and CD under the influence of south pole, lastly you can see you will get a negative voltage. So for one rotation, I can get one sinusoidal waveform. So AB is under the influence of south pole, therefore positive voltage. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . When AB is under the influence of north pole, it will be negative voltage. When it is under the influence of north pole AB, it will be a negative voltage. See, AB is under the influence of negative, north pole, negative. When same AB is going under the influence of south pole, positive voltage. So it is changing its direction. Okay. If you have any doubts till now, you can just ask me. Any doubts? You can just type or unmute yourself and ask me. Now, as I explained the physics, which most probably might have studied in intermediate, but I explained the physics. Next, I can go for our electrical circuits. Exam is already I said no. Exam is on coming Tuesday after Dasara, so that there is no problem with any one of the student. Okay, so exam is on 29th, I guess. Today is 22nd, right? Not 29th. I will tell you today, 27th. Exam is on 27th. Yeah, 27th. 12:15 to 1:5. It will be open book examination. You need to keep ready with your papers and pen and then calci. So we'll upload the paper, you solve that questions, and then you have to send to a particular mail which we will give for evaluation. And just pass on the message, let the other students also join the online classes. Okay. So I'll stop uploading the recordings from AC circuits. You can just pass on that message. So no doubts with respect to Fleming's right hand rule or else Faraday's law of electromagnetic induction or any physics related to electromagnetic induction. Anything you can ask me, because once you are clear with that basics, we can easily understand. Otherwise, this subject from now onwards, it will become Greek and Latin. Till now, it is very easy one. Okay, once you start AC, remember you should be strong with your mathematics. You should be strong with your little bit of physics basics. Then this is also a very simple subject, AC circuits. And literally you can see what is the use of all the mathematics which you have studied, like differentiation, integration, how it is applied in engineering applications. Okay, so then for 5 minutes, 1 or 2 slides we will complete about AC circuits. So why we are going to generate an alternating current? Because we can step up the voltage or step down the voltage. We can generate any shape, but we have selected a sine shape because sine can be easily differentiated or integrated. So to have a better mathematical analysis all over the world, they will try to generate a pure sinusoidal voltage. Okay, so the sine, to have a difference between AC voltage and DC voltage, all AC quantities are represented with small letters. So if there is a V, small v, that is a AC voltage. If there is a small I, that is a AC current. Okay, small p, AC power. Okay, so what is a sine wave? Sine wave is a periodical waveform whose positive cycle and negative half cycle are same, and the same periodic waveform will be repeating after each and every time period. Okay, so the inverse of the time period is called as a frequency. The frequency is equal to number of cycles per second, which is given by inverse of time period. Okay, and also you might have studied about wavelength or lambda, which when you studied about the waveforms. So unlike this water waves, which cannot be directly have the similar characteristics, the periodic waveforms are constructed from sine waves. So the sine wave will have a frequency, or the cycles will be repeating after each time period. Okay, the number of cycles per second is called frequency. So how we can represent a sine wave mathematically? So basically a sine wave is characterized by what is the magnitude of your sine wave or else peak value of your sine wave, and what is the time taken by the sine wave to complete one cycle. Any periodical waveform is characterized by time period and its magnitude. So let us take an example of this sine waveform, how we can represent this sine waveform. So you can see the peak value of the sine waveform is plus 20, negative peak is minus 20. So the amplitude of sine waveform is 20 volts. And the time taken to complete one cycle is saying 50 microseconds. Okay, so any sine wave is characterized by the amplitude. The amplitude is nothing but maximum value of the voltage or current. And then period or time period. Time period is nothing but time taken by the cycle, time taken by the waveform to complete one cycle. Okay. So next we'll study about what is a frequency. Frequency is number of cycles per second. So the frequency is always measured in hertz. Okay. So it indicates, for example, in 1 second it can complete 3 cycles. Then the frequency of the waveform is 3 hertz. How I can relate f is equal to 1 by t? So what is t? Time taken to complete one cycle. Okay, time taken to complete one cycle. So this is t. So the time taken to second cycle is another t. Time taken to complete third cycle is another t. So total time taken to complete 3 cycles is 3t. Okay. So what he is saying, that frequency is equal to number of cycles per second. Okay, number of cycles per second. Okay, so if at all we say that the time period is inversely proportional to frequency, because in 1 second it can complete, okay, in 1 second it can complete 3 cycles. In 1 second it can complete 3 cycles. So I'll ask the question, what is the time taken to complete one cycle? So it will be 1 by 3 seconds. So he mean to say the waveform is completing 3 cycles in 1 second. So I can say the time taken to complete one cycle is 1 by 3 seconds. So from this I can say frequency is equal to 1 by t. Frequency is inversely proportional to time period. For example, the waveform is able to complete 50 cycles per second. The waveform is able to complete 50 cycles per second. So what is time period? Time taken to complete one cycle. So it is completing 50 cycles per second. Then time taken to complete one cycle is 1 by 50. Therefore, the frequency and time are inversely proportional. F is equal to 1 by t, or t is equal to 1 by f. So frequency is measured in hertz. It indicates number of cycles that a sine wave completes in 1 second. Okay, so a period and frequency are reciprocal to each other. F indicates number of cycles per second. Then what is the time taken to complete one cycle is 1 by f. So given in a problem he has given The time period is 0.02 seconds. What is the frequency of the waveform? 1 by 0.02 50 hertz. So how we can represent a complete sinusoidal or cosine waveform? It is represented by I of t. I of t is the current is varying with respect to time, which is equal to Im. Im indicates peak positive value, okay, into cos or sine. You can use cos or sine into omega into t. What is omega is angular frequency. What is angular frequency? So you know 360 degrees is equal to 2 pi radians. 360 degrees is equal to 2 pi radians. If you don't remember, I will tell you how to convert degrees to radians, radians to degrees. You can use calculator, but 360 degrees is equal to 2 pi radians. So pi radians is equal to 180 degrees, or theta is equal to theta, radians is equal to pi by 180 into degrees. This is the formula. There is degrees and then radians. You can change that settings in a calculator. I'll show when we'll do the problems. We'll utilize the calculator a lot when you go for AC waveforms. I'll record those videos how to convert the radians to degrees, or keep your calculator in degrees mode and to convert degrees mode to radians mode in your calculator. Okay, so radians is equal to pi by 180 into degrees, or degrees is equal to 180 by pi into radians. So to complete one cycle means to complete 360 degrees. Okay, radians. So radians is 2 pi radians divided by time taken to complete one cycle is t. Okay, so generally a sinusoidal waveform is represented by I of t is equal to Im cos omega t or Im sin omega t, where omega is equal to angular frequency given by radians per second. How many radians it is completing per second? Okay, so a sinusoidal waveform, how we'll represent? If at all I'll say V of t is equal to 20 sine 314t. So what is 20 peak value? What is 314 omega? So omega is what? Angle by time, 2 pi by t. So 1 by t is f. So I can write down omega is equal to 2 pi f. Omega equal to 2 pi f. So I'll stop the class at this point. We'll continue next class. If you have any doubts, you can ask me.